This is a reference paper for our project. As I have been telling this we don't implement the project paper as it is. We are going to do some little additions and deletions on it, but overall our theme will be quite similar to what is this. So the abstract over here speaks the similar issues. Okay, like this is actually the scheme for DTMF. So you have basically here 16 keys. Okay, and each key here like 1. Okay, this corresponds to sending 2 frequencies. Okay, this is one frequency, 697 hertz. Another one is one second, I'll zoom in. Okay, yeah, 1209 hertz. So this is standard, okay, across all telephonic equipment and all. So we are going to use, we are going to generate this, in our digital FPGA itself, okay, based on these keys, what you press. So here in the introduction part, a bit of mathematics is explained about what is called Gaussian algorithm. Once we start working, you will get to know the Gaussian algorithm is an IEEE filter. In fact, it's an IEEE filter to implement Gaussian algorithm. So the architecture of Gaussian algorithm will be like this. You have few delay lines and adders, multipliers and all that. Actually, this paper does not describe about the FFT technique, but we are implementing FFT technique for the purpose of comparison, because we want to prove it is a low area and low power in comparison to the conventional techniques. So we are implementing FFT as well. So in the second phase, we will implement this Gaussian algorithm based technique. Then we will actually talk about, okay, now here he is talking about the resource sharing approach. So what it means is like, here, let's say you have 2 multiplication to be carried out in parallel, like AB has to be multiplied and CD has to be multiplied. Then what we can do that you can have a single multiplier, and the single multiplier you can choose to, you can control them using some muxes, and there is a controller. So what this controller does, the same multiplier first in the first clock cycle AB are multiplied, in the next clock cycle CD are multiplied. So this kind of approach is what is the resource sharing approach. So what we do here, that the Gaussian IIR filter algorithm, we are actually putting in timing, so that we need to know what should happen in the first clock cycle, what should happen in the second clock cycle, third clock cycle, fourth clock cycle. So once you do that, actually this technique what we are implementing, a resource sharing approach, is a very novel technique, because today's FPGAs are available, they can run at very high speed, like as high as 300 megahertz they can run, but all the applications don't need that much of high speed. So what you can do is you can actually have an advantage of the speed, so you run at high speed but run in a serial fashion, so that your hardware will be low hardware. So this is basically the complete block diagram. Maybe details we are going to get once we start implementing them. Okay. So then as per the timing diagram worked out, we have worked out what blocks and when to trigger them and all. And the final Gaussian algorithm implementation, it comes like this. Little complex to understand, time being. But what you can simply say, this architecture is a very optimized architecture, because we use only just one multiplier, one adder, and manage to do everything with them only. Okay. This paper talks about implementing on some Altera FPGA, but we will implement on Xilinx FPGA, because Xilinx boards are mostly used in our colleges and all. And you can as well apply on the Altera, because most of the things what we are implementing is a standard VHDL code, so it's going to run on the any FPGA platform.